empirical formulas and molecular formulas of the ionic compounds. So today we are going to do the last question based on how to calculate empirical formulas of a covalent molecule. So do you remember the format of the table? So what should be the first column? Yes. Then first column is elements. Second column is the mass. Very good. And the third is moles. Arnav and Bhavya, please start answering. And the fourth is ratio. Yes. So when you see these kind of questions where they're asking the empirical molecular formulas, you first think about of this table and start filling the columns. The information I have shown you different types of questions. The information about the masses will be given to you in different manner. So you have to work out the information, right? So what are the elements here? So what are the elements in this compound? Carbon, hydrogen, and oxygen. So one more, right? Do I have the masses of these elements? No, masses are not there. So you remember combustion analysis we were discussing yesterday? And I told you that you can use this equation that millimoles is equal to milligram divided by molar mass. Whatever molar mass, don't convert molar mass like water. In case of water, is 18 grams per mole, but the same molar mass can be written like this: 18 milligrams per millimole. I discussed with you last time. Remember this thing? Do you remember this thing, children? Okay. Can you just tell me that what is the mass of 1 millimole of CO2 in milligrams? Give me the mass of 1 millimole of CO2 in milligrams. What is it? Mhm. Mass of 1 millimole of CO2 in milligrams. I've given the example here. This is 1 mole of water, 18 grams. This is 1 millimole of water, 18 milligrams. I'm asking the same question. So do you know the molar mass of CO2? Can you work out the molar mass of CO2? Shreya, HR, Arnav. But now I'm asking, yes, yes. Shreya H is right. It is the same number, 44 milligram per millimole. Practice it. It will make your mathematics very simple. In Unit 4, we'll be doing questions based on titrations. There, I will be using millimoles. Teachers, school teachers will not be using it. But don't worry, if they are not using, you can use. Mathematically, you can be more apt than your teachers. Okay, so can you give me the mass of 1 millimole of O2? Now I want answer from all of you with units. Bhavya with units. Arnav, Bhavya with units. Yes. Gorika is here. Gorika, you're in? Yeah. Answer it. Okay. Again, Shreya H and Shreya R are first. What about rest of you? Yes, Arnav. Very good. Gorika, you're understanding this? Yes, Gorika. Very good. Bhavya, good. So you have understood the meaning of this? Okay, fine. So this is 32 milligram per millimole. Now check here. From in this question, I already know carbon, hydrogen, oxygen. They are three elements. They are doing combustion. Is combustion analysis. They are getting 10. The total mass of the sample is this. So what is the mass of the sample? So write down the mass of the sample, which is 10.68 milligram. Don't worry about milligram. Let it be like this. We can work in millimoles because we have to take the ratio. So I can take the ratio of the millimoles. I'll get the same answer. How many milligrams of CO2? 16.0201. 16.01 milligrams of CO2. I want to convert this milligrams of CO2 to milligrams of carbon because the carbon has come from the sample only. So can you tell me how to go from milligrams of CO2 to milligrams of carbon? What's the plan? I'll go from milligrams of CO2 to millimoles of CO2. Yes, keep telling me. Why using this ratio, children? This ratio, this one. Can you see? 1 millimole of CO2 is 44 milligrams per millimole. I'll use this ratio, this one, here. Then from millimoles of CO2, I can go to, yes, Shreya H, very good. Shreya R, Shreya, millimoles of carbon. So in 1 millimole of CO2, look at the formula. This is molar ratio. Look at the formula. In 1 millimole of CO2, how many millimoles of carbon are there? Yes, Korika, how many millimoles? Look at the formula. 1 millimole of CO2 has. Arnav, what happened? Are you there? Arnav, Bhavya, you're not answering, children. So you're not answering. You're not understanding, Arnav. These things we did in the previous two classes. Look at the formula. In 1 millimole of CO2, how many millimoles of carbon are there? Arnav, what's your answer? 1 millimole of what? Carbon. If I give you 1 millimole of H2O, now all of you please answer. Understand this. This is very important. If I give you 1 millimole of H2O, can you tell me how many millimoles of hydrogens are there? And how many millimoles of oxygen? Yes, Bhavya, good. 2 millimoles of hydrogen. How many millimoles of oxygen? 1. Korika, you are getting it? Good. So, so it means I can convert millimoles of CO2 to millimoles of carbon. And from millimoles of carbon, I can get the milligrams of carbon by using periodic table. By using this ratio that 1 millimole of carbon is equal to how many milligrams of carbon. Look at the periodic table. Look at the periodic table and give me this value. 1 millimole of carbon is, you have your periodic tables, is 12.01 milligrams of carbon. Are you understanding this, children, all of you? Okay. Okay, good. Now, let's start the question. I'll start with 16.01 milligrams of CO2. I will plug in the first ratio, plug in the ratio here. Then I will plug in the second ratio, plug in the ratio here. Then this ratio, milligrams to millimoles, millimoles to millimoles of carbon, millimoles to milligrams of carbon, and then the third ratio, and I'll get the milligrams of carbon. So you students are going to help me in selecting the ratio. Milligrams of CO2 to millimoles of CO2, which ratio? That 1 millimole of CO2 is, yes, is how many grams? How many milligrams? 44 milligrams of CO2. See, milligrams of CO2, milligrams of CO2 cancel. Yes, Arnav. Now, Arnav, can you tell me the next ratio? Millimoles of CO2 to millimoles of carbon. We just discussed, it's written on the whiteboard also. 1 millimole of CO2 has how many millimoles of carbon? Mhm. Yes, very good, Arnav. So, can I write down this ratio here? This one, this ratio, children. This one. Bhavya, this ratio. 1 millimole. I'm expecting Bhavya and Arnav to answer very fast. Bhavya, you should answer very fast. Are we okay till now? Anyone has problem here? Can you see millimoles of CO2, millimoles? It's the same thing, millimoles, moles. When you're working with moles, then you're working with grams. But when you're working with millimoles, you can work in milligrams. Molar masses are same. Okay. Now the next ratio. Who is going to tell me the next ratio to get the milligrams of carbon? Yes, please type it here. Yes, 12.01 milligrams of carbon divided by 1 millimole of carbon. Now cancel the units. Cancel this and you're left with milligrams of carbon. What's the answer? Give me the answer. Gorika, are you getting this ratio because you were not there in the previous two classes? You are understanding this dimensional, Gorika? Very good. 4.37, let's take 4.370 milligrams of carbon. Okay, so we have the mass of carbon, 4.37 milligram, right? But do you have the millimoles? Can you stop here, children? Here, sorry, here. Stop here, get me this answer. How much is this? Otherwise, you divide this number by this number. I need this also, millimoles. Okay, this I need very accurate, more accurate, Shreya, the way Shreya R has given, 0.3638. Okay, for hydrogen, now I have to work for hydrogen, okay? So you're going to help me for hydrogen. From where I can get the information of hydrogen? From where? From water. So I'll start with milligrams of water. How many milligrams of water are given? 4.37 milligrams of water. Okay, now please tell me the planning. From milligrams of water, I'll go to, I can calculate milligrams of water to millimoles of water. Very good, as Shreya H. Millimoles of water. And from, very good, Gorika. From millimoles of water, what can I get? Millimoles of hydrogen. Very good. Shreya R and Bhavya, your answers are slow as compared to other children. Move fast, okay? From millimoles of hydrogen to milligrams of hydrogen. Very good. So you're going to give me the ratios? Okay, let's start. 4.37 milligrams of H2O. Plug in the first ratio. Second and third. I need three. Milligrams to millimoles. Look at the periodic table. Check the molar mass. Millimoles to millimoles of hydrogen. Look at the formula. Millimoles to milligram of hydrogen. Look at the periodic table. Yes, please. What is the first ratio? Milligram of water to millimoles of water. Look at the periodic table. Check the molar mass of the water in milligrams. It's written here also. Yes? No, Bhavya with units. The way Gorika is giving me. Bhavya, see? Okay? We are not speaking, so we should type very nicely, very clearly. Millimoles of water divided by. No, but I'm asking the ratio, right? Milligrams of water. The next ratio, Bhavya. Arnav, millimoles of water to millimoles of hydrogen. Look at the formula of water, H2O. In 1 millimole of water, how many millimoles of hydrogen are there? Arnav, good. Excellent, Shreya R. and Arnav, very good. 2 millimoles of hydrogen over 1 millimole of water. We are clear, all of us? Third ratio. Now I want to, this is called as molar ratio, mole to mole. Mole to mole, we have to see the balanced equation or we have to see the formula. Third ratio, millimoles of hydrogen to milligrams of hydrogen. Third ratio, children. Yes, Shreya R, very good. 1.01 milligrams of hydrogen over 1 millimole of hydrogen. Good. I think now we can cancel the units, Gorika. Check. Millimole of hydrogen, millimole of hydrogen. Always remember what do you want will come in the numerator. Then you will see all the things automatically they are taken care. You need not to worry. You must check whether I have done the right ratios by cancelling the units. This is check step. I'm checking. I'm checking whether I have done everything correctly. 4.37 times 1, all numbers of the numerator here. All numbers of the denominator here. Unit left, milligrams of hydrogen. That's what I wanted. Children, I need you to give me the milligrams of hydrogen and you have to give me the millimoles of hydrogen. Both the things. So stop here. And get the millimoles of hydrogen. And then multiply it by 1.01 to get the milligrams of hydrogen. So first give me the millimoles of hydrogen. All of you are doing calculation. Okay, Shreya R is saying that millimoles of hydrogens. Okay, Shreya R, Shreya H, both of them are with the same numbers. Bhavya is also with the same number. Very good, Bhavya. So all of you must be correct. So we have 0.48 0.55 millimoles of hydrogen and the grams are 0.4904. How come you are so accurate with your numbers? Oh, Gorika is also like that. Okay, good. Now, what is next? Oxygen. I need to know the milligrams of oxygen. I cannot use the oxygen of the water and of CO2 because that's coming from the air also. So, how to know the oxygen in the given sample, the mass of the oxygen in the given sample? So, now I'm worried about oxygen. So, what is the milligrams of oxygen? How to calculate? You know the milligrams of carbon, you know the milligrams of hydrogen. So, milligrams of oxygen will be the total mass of the sample, which is also in milligrams, minus milligrams of hydrogen plus milligrams of carbon. Law of conservation of mass. Law of conservation of mass. How much is this? Okay, Shreya R is giving me the answer. Anyone please confirm this? Is this answer right? Okay, this answer is right. Shreya R, Shreya H, again, the first one to answer the question. Why you children are taking so much time for such simple questions? 5.8196. Can you work out the minimoles now? Children, please don't relax on your chairs. Sit straight. Okay. Sometimes I see the videos of the student, they are just lying down on the chair. No, sit straight and answer the question very fast. So how many millimoles of oxygen, Gorika? You have the milligrams. And you know that 1 millimole of oxygen is 16 milligrams. Use the periodic table. So you just divide your milligrams of oxygen by 16, right? I gave you more equations, like simple equations, like you can calculate number of moles or millimoles by taking the mass divided by molar mass. So remember these equations also. Of course, dimensional is really good, but sometimes we just want to get rid of the question very fast. Then you can use this also. Okay, Shreya H and Shreya R are again with the answer. What about rest of you? Arnav, can you use this equation, Arnav? And this ratio to get the millimoles of oxygen? 0.3635 millimoles. Bhavya is also giving me the answer. 3635, all of them are. Okay, only Shreya H is slightly different, but last digit can be different. So don't worry about it. Okay, so which number is the smallest? Keep thinking with me. Keep answering whatever I'm asking. Gorika, which number is the smallest? The oxygen. Okay, pick up that number. Divide by, because the chat messages are the way you are talking to me. So I want all of you to think with me and keep answering here. So this is 0.3638 divided by 0.36. You are going to divide all these moles by the smallest number to get the simplest ratio. But the aim is to get the simplest whole number ratio. What is this number? Here, here. Second one, hydrogen. Your calculators are next to you. Okay, children. Such simple calculations, so much time. Gorika is saying 5, 1. Is it Gorika? I don't think. Don't approximate. Oh, you cannot approximate 1.33. Do not approximate. You can approximate 1.01, 1.1. But after that, you cannot. 1.2, no. 1.3, no. That's the reason they are saying be careful. Do not round off. Okay, so don't approximate 1.33, which I can say 1.34. Okay, and this one is 1. Now what should I do? Because my number is not a whole number ratio. I have to think about a smallest factor. You can start with 2. Is it helping? No, it's going to make it as 1.68. I cannot approximate 1.68. So go for next. Going for next. Next number is 3. Is it helping? Yeah, keep saying yes, no in the chat. Bhavya, is it helping? Oh, come on, dear. Why? 3 times 1 is 3. 1.34 times 3 is 4.0, right? 2. That is 4. Yes. It's helping, right, Shreya? Bhavya? Okay, and then this. Okay. Gorika, any problem in understanding this? Okay. So what's the empirical formula? These are the ratios. So the empirical formula, very good. Shreya, see, these girls are thinking very fast and answering very fast. So think fast and answer fast. They are thinking with me. Whatever I'm saying, they are totally connected with me. They are not even missing one single sentence spoken by me. So be like that. C3, H4, O3. That's the empirical formula. But they are asking the molecular formula also. So what should I need to know here to know the molecular formula? You remember? N. N is the molar mass divided by empirical formula mass. Start doing the quizzes. What is the molar mass? Given 176.1. Very good, Shreya H. She's totally thinking with me. What's the empirical formula mass? Calculate. Very good, Bhavya. Calculate this. Yes, Arnav. Good. Calculate the empirical formula mass now. Here you need not to be very accurate. You can take approximate molar masses to go very fast with your calculation. It's 88. Yes, 88 grams per mole. So what's this ratio? You know, once I have this 88 in my calculator, I just press inverse times 176. So if you use your calculator, you will know all the tricks also, which can make you more faster in using your calculator too. So what's the molecular formula, children? The molecular formula is C6H8O6. If it is a free response question, how I'm going to do it? I'll make this table. I show the calculation the way I was showing milligrams of CO2 to milligrams of carbon. I'll show that dimensional complete. Show your work for free response. And you will get free response questions in on my website also in the final test. Then you can go from milligrams of water to milligrams of hydrogen. Then you show how you are calculating the milligrams of oxygen. Then take the ratio, then complete the table. For the table, you need not to show anything. You can show everything in the table only. Then write the empirical formula. Then show this formula, this one, that you are using this formula. Calculate this N. And then write down that the molecular formula is C3H4O3 and then put this N here and write it like this. Show all steps. So it's a kind of free response question. Are we okay with this question? So this was the last question. Now you can practice questions from the Zumdal book and you can practice questions from the website also. More you practice, more you learn. Okay, now I'm telling you the next important concept is called as Gay-Lussac's law or Avogadro's hypothesis. Hypothesis, you know, that is something without any something like we need experimental proof for that. But finally, this is Avogadro's law in unit 3. So what we are learning is actually Avogadro's law. So let's see what this law is going to say. The law says, please understand every word. It's very simple, but very, very important. The law says that if you have gases, first of all, this law is all for gases only, for gases. So do not try to use it on solids and liquids, only for gases. Avogadro's law, Gay-Lussac's law, Charles' law, ideal gas law, they are gas laws, so only for gases. Here you can see this equation, this one. Everything is in gas. Can you read this equation in terms of moles? How many moles of hydrogen are reacting with how many moles of chlorine to give you how many moles of hydrochloric acid? Hydrogen chloride. Yes. Can you read it? How many moles of hydrogen gas? Look at the balanced equation. Can I say one more? The coefficient is 1. How many moles of chlorine gas? You don't know how to read equations in moles? You were using molar ratio. Yes, the way Shreya H is saying. One of this reacting with one of this, giving you two of this. This is in terms of moles. Yes, Bhavya, Arnav, this not clear? Gorika, are you okay with this? So why you people are not answering? Is it difficult to type, Arnav? Okay. I won't answer here. Notes are already there on the website. Recordings are there. You can make notes again if you want. Watch the video recording. Make notes nicely. But right now, interact with me, answer my questions. 1 mole of H2 reacting with 1 moles of Cl2, giving us 2 moles of HCl. Correct? Now, let's see this Gay-Lussac's law. If the temperature and the pressures, temperature and the pressure of these containers are kept constant, means they are at the same temperature and same pressure, all these gases, then this molar ratio is the ratio of the volumes also. Because later on, when we are going to learn this law, Avogadro's law, that equal volumes have equal moles. For gases, this one. Can you see the volume of H2 gas here? Is it same? Volume is same? Am I right? If this is one volume, this is also one volume. Can you see the moles are also same? Equal volumes have equal moles. But what is this volume? It's double of this. 2 volume. So what happens to the moles? Doubled. Moles are doubled. So what is Avogadro's law? Gay-Lussac's law is this, but now I'm converting this into Avogadro's law. You're already aware of Avogadro. You have done Avogadro's number. So what is Avogadro's law? So write down this law, or it will come again in unit 3. Equal volumes of gases have equal moles at the same temperature. For T for temperature in chemistry, P for pressure, at the same temperature and pressure, and V is for the volume. V volume, T temperature, P pressure, and what is N? What is N? Anyone? What is N? Gorika, what is N? Bhavya? Yes or no? Very good. Bhavya, when I call your name, I want answer. Please give answer. I want answer from you, Bhavya. Not yes or okay. Okay? So what is N, Bhavya? Yes, Korika. Very good. Yes, Bhavya. Good. Okay. So Avogadro's law is clear. Now I'm going to use this Avogadro's law on the equation. Different equations. First equation, I'm going to clear it. First equation is this one. If I give you 20 liters of H2, then can you tell me 20 liters of H2 will combine with how many liters of Cl2? How many liters? See, 1:1 ratio. You can read the complete equation in volume. Yes, 20 liters of Cl2. And how many liters of hydrochloric acid you will get? 40 liters. Yeah, that's the answer. That's the importance of this law. You can apply this law, Gay-Lussac's law, Avogadro's law, on the balanced equation. You can read the coefficients as volume. You are understanding this? Let's see this question. If I give you 60 liters of O2, can you tell me 60 liters of, sorry, H2? 60 liters of H2 will combine with how many liters of O2? Okay. Yes, very good. 30 liters of O2. And how many liters of water I'm going to get? Arnav? I'm going to get, why 90? Don't add. Okay, see here. There is no law of conservation of volume. Shreya, you don't use law of conservation of volume. There is nothing like that. There is only one law, law of conservation of mass. right? So it is 60 liters of H2O. Because this is 60, 2 is to 2. Or you take double of this. Shreya H. Okay, good. You have understood this? That there is no adding of the volumes to know the final volume here. Okay, the volume is, there is no law of conservation of volume. Volume will be decided by the amount of the gas. Okay, now I'm going on the next question. Read this question. This is the law which we have already done. Now, can you write down the balanced equation here, children? By looking at the volumes. 2 volumes of hydrogen means 2. What's the formula of hydrogen gas? What's the formula of hydrogen gas? H2 gas. Reacting with 1 volume of oxygen. What's the formula of oxygen gas? 1O2. Giving you how many volumes of water? How many volumes? 2 volumes of water. Okay. Ready for this question? So you can see these are the 3 balloons at the same temperature and pressure. All the 3 balloons are at the same temperature and pressure. Now they're asking that how much is this volume if the moles are 2? So can you see that when the moles are 3, how much is the volume? 30. So if the moles are 2, how much should be the volume? Yes, Shreya, very good. It should be 20. Ratio 3 is to 30. 3 is to 30 means 1 is to 10. Then if I multiply this 1 is to 10 by 2, because here there are 2 moles, so it becomes 2 is to 20. Can you work out here? Yes, this is 4.45 moles. Okay, so I can give you equation for this also. The equation goes like this. The number of moles of this first balloon, this is first balloon, this is second balloon, this is third balloon. The number of moles in the first balloon divided by the volume of the first balloon is equal to number of moles of the second balloon divided by is equal to number of moles of the third balloon divided by volume of the third balloon. Now, for the first balloon, you can use this. What do you want to calculate? V1. So plug in the values. What is N1? 2. What is V1? I want to calculate. See, this is V1, this one. What is N2? 3. What is V2? 10. Use this ratio, get V1, which we just calculated. Oh, this is 30, sorry. We calculated it as 20 liters. Is this equation more comfortable? This is Avogadro's law. Arnav, is it comfortable, this equation? Arnav, you're there? Okay. Now, let's see this one. And use this. What is N2? 3. What is V2? 30. What is N3? We don't know. What is V3? N3 we don't know, right? And this is 45. Get the value of N3 from here. And you will get the answer as 4.5 moles. So please write down, this is Avogadro's law. Equal volumes have equal moles at the same temperature and pressure. So when you take their ratios, they are equal. Bhavya, you're back? So I'm going to clear this. Ready for next question? Okay, read the question very carefully. They're asking the formula of the product. So let's write down the balanced equation. Ready? 1 liter of chlorine gas. Formula is given. Cl2. 1 liter means 1 mole. Combining with 5 liters of fluorine gas. So I can take it as 5 F2 gas. Is it okay? Giving you 2 of the formula of the product, XY. We don't know the formula. Can you predict the formula now? How many chlorines are here? How many fluorines? Gorika? How many fluorines? Is it chlorine or fluorine? What are you writing? Children, my audio is okay? You can hear me properly? My audio is okay? Okay, good. Chlorines are 2. My question is now on the fluorine. How many fluorines are there? Yes, 10. Yes, Shreya are. Very good. Now in this formula, 2 is already here. Chlorine will come first, then fluorine. So how many chlorines should I write? Is the chlorine taken care if I write 2 in front? Is it taken care? So now fluorine. How many fluorines? Yes, this is the formula. See, by using this Avogadro's concept and Gay-Lussac's law, we derive the formula of the compound. We check the volume of chlorine reacting with the volume. Children, do you need more time to read the question? Because maybe I'm slightly faster, not giving you sufficient time to read. Gorika, are you getting sufficient time to read the question? Or should I slow down? Gorika, please confirm. Are you getting sufficient time? Bhavya, Gorika and Bhavya. Okay. So let's read the question again. There is a reaction of 1 liter of chlorine gas. You know, we said equal volumes have equal moles. If this is 1 liter, it's reacting with fluorine gas. This is 5 liters. So it means their mole ratio is also same. It means 1 mole of chlorine gas reacting with 5 moles of fluorine gas. Is it okay? Till now everything is fine? Please confirm. Arnav, you have understood this language? That how I have written this equation. Arnav, yeah. Now is giving you the product. Formula of the product we don't know. But we know that the product is made up of chlorine and fluorine. So I'm just writing here X and Y. And the number, what is the number in front of this? What should be the number? How many liters of this XY is formed? You are reading the question. Yes, Shriya H, very good. 2. Now use the number of chlorine atoms, use the number of fluorine atoms, and make out the formula of this XY. Always remember the element which is less in number will always come first. Like here you have only 2 chlorines, here you have 10 fluorines. So this should come first. So X is chlorine, Y is fluorine. So can you work out the formula now? This 2 is already in front. This is the balanced equation part. Yes, what's the formula? Shreya R, where are you? You're not answering. Shreya, again, these two girls are first to answer it. What about Bhavya, Gaurika, Arnav? We are clear about it? Okay, I'm worried today for this is a new concept and you people have become very slow in understanding this. But I hope these examples are helping you. Can we do one more question? Let's do this. Take these numbers as the mole. Can you tell me how many moles of nitrogen gas is here? Look at the picture. Okay, read the question. How much is this volume? Yes, one volume. How much is this volume? How much is this volume? Okay, one volume means what should I write here? 1 and 2. What should I write here? 3H2. What should I write here? 2XY. I have to work out this formula. Who is X? Nitrogen or hydrogen? I told you the one which is less in number. Who is X? Yes, this is X. And this is Y. So what can be the formula of XY? Nitrogen is 2, hydrogens are 6, this 2 already in front. So what can be XY? Again, Shreya R and Shreya H are the first one to answer. It is 2NH3. Yes. Gorika, you're getting it? Yes, good. It's 2NH3. NH3 is the formula. You know, children, earlier in around 1800, when people were not aware of electrons, protons, electrons, protons, they are discovered around 1890 or 1900, around there only. Before that, how people were working with the formulas and how they were deriving all the formulas and doing the chemical reactions without the knowledge of valence electrons and charges, by using these concepts, by using Gay-Lussac's law, by using Avogadro's law, they were able to make out the formulas. You are understanding this? Here, the way you did exactly in the same way they did the experiment and they worked out the formula of the product. Okay, now this is the concept of your Gay-Lussac's law. One last question from my side. If I give you a reaction in which a gas Cl2 reacting with methane giving you CH3Cl gas plus HCl gas. All of them are gases. Gas. If I give you 20 liters of Cl2 gas, can you tell me 20 liters of Cl2 gas will react with how many liters of methane? Methane is this one. This is methane. 20 liters of Cl2 will react with how many liters of methane? Waiting for the answer. Yes, Shreya R. Very good. 1:1. Equal moles have equal volume. Very good, Bhavya. Yes. Gorika, equal moles have equal volumes. If Cl2 is 1 mole, CH4 is 1 mole. If I say Cl2 volume is 20 liters, then exactly same volume is needed for methane. Now, can you tell me how many liters of CH3Cl will form? How many liters will form? If I take 20 liters of Cl2, how many liters of CH3Cl will form? Check the molar ratio, mole to mole. Same ratio will be with the volume. Shreya H and Gorika, are you understanding this? Yes, 20 liters. What about rest of you? What are you thinking? Isn't it 1 mole of Cl2, 1 mole of methane, 1 mole of methyl chloride? So their volume should be also 1 volume, 1 volume, 1 volume. The ratio is 1:1:1. So if I'm taking this 20 liters, then this is 20 liters, then this is 20 liters. Yes, Bhavya. Please ask your question if something is troubling you. Because when you start asking question, then things will become more better. What about HCl? How many liters of HCl will form? I want answer from all of you. Yes, that's the fast answer. Arnav, Bhavya, Arnav. Okay, good. So now this topic is done. You practice some questions on the website. Now there is another topic. We call it as hydrates. These salts, many salts, like magnesium chloride. Can you give me the formula of magnesium chloride? Look at the periodic table. Check what is the charge on magnesium and what is the charge on chlorine. How many electrons magnesium can lose or gain? Yes, magnesium. Why the answers are so slow? You have the periodic table next to you. So magnesium is in first group or second group? Children, you are slowing down the class. Arnav, magnesium in which group? And all the time you should have your periodic table when you are taking the class. I cannot share periodic table, then where the question will go. Is group 2. So what is the charge on magnesium? Group 2 elements have, you have not done the unit 0. Unit 0, children, I'm going to announce the results very soon. Magnesium 2 plus. And chlorine. What's the charge on chlorine? Look at the periodic table. How many electrons it can gain, lose? Yes or no? Very good. -1. So what's the formula of magnesium chloride? Give me the formula. When you're making the formula, the charges should be. Yes, very good. MgCl2. This is a ionic compound or covalent molecule? Ionic. These ionic compounds, when they are present in the nature, they take some amount of water with them. So it has X moles of water also. Like for example, sodium carbonate. It's an ionic compound. It has 10 moles of water with it. And this number is fixed. And these are called as hydrates. Hydrate means water is there. Similarly, magnesium chloride is going to have X moles of water. This X is a fixed number. That's what they're asking us to calculate here. What is X? That's what they're asking us to calculate. So understand the meaning of hydrates. These are the ionic salts with water molecules trapped in them. And these water molecules have fixed number. So in the coming questions, we'll calculate the formula of the hydrate. We'll calculate that how many moles of water are there. Means the aim is to know this X. Now if I look at this formula, what can I say? Can I say 1 mole of magnesium chloride has how many moles of water? Can I say X moles of water? 1 mole of MgCl2 has how many moles of water? X, not 1. X I have to work out. Like what can I say for this one? Now I want answer from all of you. 1 mole of sodium carbonate has how many moles of water? Yes. How many? Look at the formula. Answer it. 1 mole of sodium carbonate has how many moles of water? Again, Shreya R and Shreya H are the first one. Okay, Bhavya, Gorika. Arnav, you are listening? What's the answer? Arnav. Arnav, are you there? So why are you taking so much time to answer such simple questions? So children, are you clear about the formula of the magnesium chloride and the meaning of the hydrate? So I'm going to write down a hydrated sample of magnesium chloride. So I'm writing the formula MgCl2xH2O. They are saying it contains 53.18% of water. How many water molecules means this X value? They're asking us to work out the X value. Yes. When something is given to you in percent, what can you assume? Can I say, let's say the sample is 100 grams, right? Can I say that? Sample is 100 grams, right? Can I say that? Then what is the grams of water? What is the grams of water in this 100 gram? Very good, Shreya H. 52.18 gram. Very good. Can I convert this grams of water to moles of water? So how many moles of water are there? Yeah, get me the moles of water, Arnav. You know the molar mass of water? You can use this equation, N equals to mass over molar mass. Get the answer. Yes. How many moles of water, children? All of you know the molar mass of water? I'm already ready with my answer. Yeah, so how many moles of water? How many moles of water are now? Yes, Shreya H is very right. I'm also ready with the answer. It's 3.0. Actually, it is 2.899. Okay, let's take it as 3.0 moles of water. Gorika, yeah, good. Yeah, Arnav is giving me, I'm also getting the same. So let's try to be accurate because we are going to take the ratio. 2.896. Okay. Can you tell me what is the grams of MgCl2 in this sample? Grams of MgCl2 in the sample. All of you, please do calculation. How to get the grams of MgCl2 in the sample? You already know the grams of water. Yeah, subtract these two. Subtract. And it is 46.82 grams. Can you get the moles of MgCl2? Moles. Yes. To know the moles, I can use this equation again. This one. Mass divided by molar mass. Mass is 46.82 divided by the molar mass of MgCl2. How much is that? Look at the periodic table, work out the molar mass. And children, I'm already with the molar mass. And the answer. Okay, Bhavya is and Shreya are saying 95.211. That's right. Get the moles, Bhavya. Get the moles. Yes, I'm also getting the same. 0.4917. Very good. Very good, Shreya H and Shreya R. Fast answers. Bhavya, good. Gorika, where are you? Okay. Are we clear till now? Now, in 100 grams of water, I know the moles of water. I know the moles of MgCl2. Now check here. And in this formula, if I say that there are X moles of water, these X moles of water are present in 1 mole of MgCl2. Agreed? If I take the same ratio here, the moles of water are these. 2.896 moles of water are present in 0.4917 moles of MgCl2, right? Gorika, you're with us? Gorika. Okay. You're understanding this ratio? Children, all of you are understanding? Because the formula is telling me the ratio of the moles of water with MgCl2. I already know the moles of water and the moles of MgCl2 in my sample, 100 grams of sample. So I'm taking that ratio. How much we are getting this? What's the value? What is the value? I'm getting 5.88. Yeah, 5.889. Can I approximate it? Now I can approximate it 6. So what's the formula of the hydrate? The formula of the hydrate is MgCl2 6 water. And that was the question. I'm giving you a minute to see all the procedure, how we started and how we landed up with the answer. Then I'm going to erase it and then I'm going to ask me to tell me the steps, how to start and how to get the value of x. Please go through it. Can I clear it now? Shall I clear it, children? Okay, let's start. How to start? What was the first point? When you are reading the question, they have given the percent of water and they are asking the magnesium chloride hydrate. What is the starting point? The starting point is formula of hydrate. What was it? What was it, Arnav? We assumed it as MgCl2 XH2O. Hydrate, hydrate. This is the starting point that you write down the formula of hydrate with X moles of water, and the aim is to know this X. Then what is the second thing which we said? Yes, we said this hydrate, the sample is how many grams? 100 grams. Yes, Gorika. From this sample, I worked out the mass of water, right? And then moles of water. This is what we did, Bhavya. Remember? And then from the mass of the water and the sample, I worked out mass of MgCl2 and then moles of MgCl2. Please, children, don't hesitate in asking questions. If you are not understanding, do let me know. Now, once I'm with the moles of water and moles of MgCl2 in my sample, which sample? This 100 gram. Then I'm taking the ratio from this formula that X moles of H2O divided by 1 mole of MgCl2 is this moles of H2O, which we calculated over the moles of MgCl2, which we calculated, which is equal to, which calculated as 6, you remember? This is how you have to do these type of questions. So we are moving on. So I have explained that question twice. I'm expecting you to help me with this question. Ready? Read the question. Give the formula of the hydrate first. Mhm. What's the formula of the hydrate, Bhavya? Copper 2 chloride. Copper 2 means copper has 2 plus charge. Transition metals, their oxidation number, their charges are indicated by Roman numerals. Unit 0, children. Shreya H, Shreya R. What's the formula? Okay, give me the formula. Yes, Shreya R. Very good. Gorika, good. But hydrate. So can I say the formula is CuCl2? Yes, very good, Shreya H. Very good. Excellent. That's what I said, that you have to assume it like this. So now do I need to work here with 100 gram, or is the sample, the mass of the sample is given? The mass of this sample is given? Yes, is given to us as 34.1 grams. Now they are saying they are heating the sample, heat it to drive off water. Water is driven off. Means when I heat, what will happen? Heat it, what will happen? This water will go away. And what is left? What is left after you remove the water? Cl2 solid. It's an ionic compound. All ionic compounds are solid. This I'm going to call it now anhydrous. Anhydrous means without water. So mass of the sample is 34.1 gram. These are the masses. 34.1 gram. How much mass of the CuCl2 left? Yes, what is the mass of CuCl2? The anhydrous sample is given in the question. 26.9 gram. Bhavya, you are with me? Yeah, good. So from this information, can I work out the grams of water and then moles of water? Can I work out that? And from the grams of CuCl2, can I work out the moles of CuCl2? Moles of CuCl2. Yes, give me this information. Then we'll take the ratio that X moles of water from this formula divided by 1 mole of CuCl2 is equal to the ratio. Gorika, now please give me the moles of water. First, calculate the mass of water from the given information. Then convert that into moles of water. How many moles of water? I already calculated. I'm teaching and doing calculation faster than you people. Shreya H, Shreya R. Okay. Can you tell me how many grams of water you calculated? Grams of water. Grams of water, Gorika, in the sample. That's the molar mass which you are giving me. Here, grams of water. Is heated to drive off the water. Yes, 7.2. 7.2 grams. Now convert this into moles. Yes, very good. 0.4 moles. So you know the moles of water, right? 0.4 here in the numerator. Can you work out the moles of CuCl2? The mass is here. Arnav and Bhavya, please don't make me call your names. If I'm not calling your name, you're not answering. That's not good. So please don't wait that I should call your name only then you'll participate here. Get the moles of CuCl2. Give me the molar mass first. Molar mass of CuCl2. Look at the periodic table. Oh, these are the moles of CuCl2. The point 2 is the moles of CuCl2. Bhavya and Shreya. Shreya H, Shreya R, they are giving me the moles of CuCl2, point 2. Okay, great. That's very fast. Perfect. Now plug in here. Get the value of X, children. Bhavya, get the value of X. X is 2. Give me the formula of this hydrate. Type the formula of the hydrate. The formula of the hydrate. CuCl2 dot. Put a dot. 2H2O. Very good, Shreya H. Very good, Shreya R. Good. Perfect. So that's the formula of the hydrate. So is this question clear? Because this question is a lab-based question. They will give you information as you are working in the lab. Like the way this question is on the top, you can see how the information is given. So it's a lab-based question, right? They will give you the mass of the sample of the hydrated salt, and they will say, okay, we have heated. This question is always there. When we have heated the sample, the mass is reduced to this much. Then when you're heating the sample, definitely water goes off because water is only the thing which is volatile and can vaporize. So from there, you can calculate the mass of the water, you can calculate the mass of the ionic compound, then get the moles, take the ratio of the moles to know the value of X. Very important question, children. So please practice. Lab-based question. Okay, moving on. Read the question. This question is very simple. Remember that whatever mass is given to you, the percent composition remains constant. Remember H2O, H2O2, we were doing in the last class, percent composition. So whatever mass is given, it doesn't matter. You're going to calculate the percent composition from the formula, this formula, right? Okay, they're asking in the original mixture, this formula, sorry, this formula, not this formula, from this. So how to calculate the percent of sulfur is N times The atomic mass of sulfur, which is 32, divided by the molar mass of the compound. Molar mass of Na2S2O3 7H2O multiplied by 100%. I gave you this equation in the last class. Can you work out this question, children? Get the percent of sulfur. What is N here? What is N here? N is 2. Very good. Because number of sulfur atoms in the formula unit, just plug in all the values. Plug in the molar mass of Na2S2O3 with 7H2O and get the percent composition. All of you are working on it? Mhm. Okay, Shreya H is giving me the answer as 40.51. Arnav is also giving the same. Bhavya is also 40.51. That's really good. Very good. And Gorika? Now I'm taking you now on the next question. Ready? Now the questions are changing. These questions were, all these are lab-based questions. This question was on the hydrate. This was on the hydrate. I'm expecting that you have understood these questions very nicely because you are not asking questions. Please don't hesitate in asking questions. I have a very special group running. They have nearly half done with the syllabus, more than half. And they are asking so many questions here. And they are doing quizzes. They are competing with among themselves. Every day I'm getting nearly 5, 6 submission from them. They are learning very well, very, very well. So please start asking questions. Don't hesitate. Okay, look at this question. Read it very carefully. Give me the formula of copper 2 oxide. Hmm. Yes, Shreya H, very good. Copper 2 oxide is CuO. So how many grams of copper 2 oxide you are starting with? Is it pure or impure? Is this copper 2 oxide 5.0 gram, is it pure or impure? It has some impurity? Yes or no? It is impure. See, containing an inert contaminant. Contaminant means some impurity is there. So it means all 5 gram is not copper 2 oxide. Something else is also there. We don't know how much is that. So is the first line clear, Arnav? Arnav, first line is clear? Okay, now. And when they were doing work with this sample of copper 2 oxide, they found that it has 3 grams of copper. So this 3.0 grams of copper, is it pure or impure? This copper, is it pure or impure? They converted this into copper. It is pure. Very good. Very good. It is pure. If it is pure, can I convert this 3.0 grams of copper to moles of copper and then to moles of CuO and then to grams of CuO And these are the grams of CuO, which will be definitely less than 5, and this is of pure. The pure amount which is present in 5.0 grams of the impure sample. And then I'm going to use this equation of percent purity. The mass of the pure sample, mass of pure CuO divided by mass of impure CuO, impure sample. The starting word 5 gram, that is impure sample, multiplied by 100%. So questions will be there based on it. Can we do it? Yes, children. Set up the ratio. This one. Is this method clear? And I'm sure that all of you are now smart in setting up the ratio. 3.0 grams of Cu. Give me the first ratio to get the moles. Get the moles using the periodic table, molar masses, atomic masses. Yes, give me this ratio. Bhavya, give me the ratio, first ratio. Yes, very good, Shreya R. 1 mole of copper is 63.55 grams of copper. Give me the next ratio. Moles of copper to moles of copper oxide. Mole to mole. Look at the formula. CuO. In 1 mole of CuO, how many moles of copper are there? Gorika, very good, very good. 1 mole of what do you want should come in the numerator. 1 mole of CuO divided by 1 mole of Cu. Now get the grams of copper oxide, copper 2 oxide using the periodic table, the molar masses. So what is the ratio here? Mhm. Okay, very good. 79.55 grams of CuO divided by 1 mole of CuO. Cancel all the units. Check whether your ratio is correct or not. Check. Check is very important. As a teacher, I also do check. After doing so much work, I don't want to be wrong. In the examination, we don't have time to be wrong. So it's better to keep checking everything. Wrong means do it again. And again, you are going to spend the same amount of time. How much is this? Yes, Arnav, how much is this? Okay, Shreya R is giving me answer with very high accuracy. Okay. Arnav is also confirming it. So, yes, Arnav, Shreya R, Shreya H, very fast in calculation. Calculate the percent purity. Use this equation. Good, Bhavya. Get the percent purity, Bhavya, now. So what's the mass of the pure copper oxide? This much. Oh, this is CuO, yes. CuO, please. Okay. 3.755 grams, CuO. This is pure. And how much was the impure? Yes, Gorika, good. How much was the impure? 5.00 grams of Cu sample. So let's write on this as sample, impure sample, multiplied by, yes, Shreya H. See, in every sentence, I have a question. But in this class, Shreya H and Shreya R, they are listening every word and answering every question. Whatever I'm saying, if I'm asking question, they're answering immediately. It's 75%. Very good. Is it understood? So this is one type of question which is based on percent purity. Okay, let's go to the next type of question. Yes, here. Read the question. Hmm. So whenever they have given you information in percent, what can you assume? You can assume that calcium carbonate is 100 grams, right? Impure. This is impure. This is impure. So what is the amount of the impure calcium carbonate? 100 grams. Okay. So impure calcium carbonate is 100 grams, right? And in this 100 grams, how much calcium is there? Pure calcium. Pure calcium is how much? 30% of 100 grams. Very good. Now this question is exactly same what we did earlier. So 30% of 100 gram is 30 grams of calcium. This is pure. Now, can you tell me the planning, children? How can I use this 30 grams of pure calcium in the given sample to get the grams of pure calcium carbonate? Yes, please. Exactly same question we did earlier. You will go from grams of calcium to mhm, this is pure. Start with this. You're understanding my question? Shreya H is perfectly correct. Very good. You will go from grams of calcium to moles of calcium. And from moles of calcium, you will go to moles of calcium carbonate. And then you will go to grams of calcium carbonate. Okay, Gorika, question for you. You have understood this method, this planning? Is there any doubt in this planning, Gorika, anywhere? Gorika, Bhavya, Arnav, please confirm here. Because if you are not able to make out what we are writing here, then you won't be able to do these type of questions. Arnav. Okay, Gorika. Arnav. Okay, Bhavya, good. Okay, good. Then do the calculation without my help. I want the answer of the pure calcium carbonate. All of you, just give me the final answer of pure calcium carbonate. And don't look at the whiteboard. I will be writing on the whiteboard because the class is getting recorded. So the children today, many students are not here. Please don't miss the classes. So they can see the answer in the recording. That's why I'm writing here. So you don't look at the writing part. So please answer here. I'm not explaining anything now. Oh, that's good. That's good. Very good, Shreya R. Get the percent. Percent purity. The percent of calcium carbonate. The purity of the sample. Mhm. What is the initial amount of the sample? Get the percent purity, children. No. Initial amount of the sample was, impure sample was, Borika. We assume that the sample is 100 gram. In that 100 gram, there was 30% calcium. So from there, we calculated 30 grams. So what was the initial amount of the sample of the impure? 100. How much is pure? 75. So 75, the pure amount divided by the impure sample multiplied by Gorika. You are getting it? So it's 75%. Is it clear to all of you? Bhavya and Arnav. Bhavya, did you calculate 75? I think I got answer 75 only from, yeah, Bhavya calculated. Yes. Good. So we are understanding these questions are based on mole concept, how to go from grams to moles in different scenarios. These are lab-based questions. So they will convert this question in the form of a lab question. And then you have to think, okay, grams to moles, all these things you have to use there to get the answer. Okay, ready for another question? Hmm. These are percent composition question, means percent purity. In the given sample, how much percent is the pure one? These type of questions. Read the question. Okay, ready to answer my question? What is the mass of the sample? Mass of sample. And the question is given. Very good, Shreya R. Shreya H. Very good. This one, this sample has two elements, gold and silver. They are asking you, it's an alloy of silver and gold. And they are asking you to work out the percent of mass of gold in the sample. mass percent of gold. What else is given to us here? What else is given? I have to start with something given to me. Sample mass is impure, right? This one is impure. What else is given? Yes, children, what else is given? This one. And this is pure AgCl, pure. And this you are getting after this reaction. Is this reaction balanced? Is it balanced? No. So balance it first, then we'll talk about it. So when you look at the reaction, the way I said, oh, this reaction, okay, is this balanced? This should be always a question in your mind. Look at the equation and ask yourself, is it balanced? No. So let's balance it first, then we'll talk about it. So let's balance it. Who is going to help me? Balance this equation, reaction 1. There are 2 hydrogen. So 2 HCl. There are 2 Cl. So 2 AgCl. There are 2 Ags. So 2 Ag. Is it balanced now? Children, you have done the balancing of equation with me in the last class. So please do the quiz. Finish it. Do the quizzes when you are learning the topic. When you will open it after a month or 10 days, everything will evaporate. Then you are back to square one, scratching your brain. What was it? What was it? Like this. So my advice is whatever you are learning during your Saturday, Sundays, like on Saturday, finish it by Sunday. And what you are learning on Sunday, you have the full week, but don't delay. When you delay the things, then you start forgetting it. So my advice is don't delay by more than 1 day. Your retention is very high for next 4-5 hours. After that, things they start vanishing out. So equation is balanced. So how much is AgCl? 7.839 grams of AgCl, which is pure. It's pure compound. AgCl is pure. From this grams of AgCl, what can I calculate? Can I calculate grams of silver? Yes or no? And give me the method. I can calculate grams of silver, pure silver, present in this 10.0 grams of the alloy. I can easily calculate this. Can you give me the method? Can you tell me how to go from grams of AgCl to, and then 2, and then 2? Yes, Korika, help me out. From grams of AgCl, what can I calculate? Mhm. Okay, Shreya R, Shreya H, Bhavya, Arnav. And Shreya R is perfectly correct. Beautiful. Beautiful, Shreya R. Grams of AgCl. From grams, the only thing which you can do is moles of AgCl. And from moles of AgCl, you can go to the, yes, very good, moles of silver. And then to grams of silver. Can you do the calculation, children, without my help? So I'm doing it for the recording, and you do it and show me your answer here in the chat, all of you. Start with this much, grams of AgCl is not Cl2, it's Cl. What's the answer? Okay, Shreya R is giving me 5.9011 grams of silver. Is it correct? Okay, all of you are there. Okay, Bhavya. So now you have the grams of silver in the given sample. The other element is gold. So how many grams of gold are there? You know how much silver is there, right? So can you give me the grams of gold? Okay. So the grams of gold is 4.0989 grams in the given sample, right? So what's the percent of gold? Children, all of you are getting this much? You know the total mass of the your electrum sample, which is an alloy of gold and silver, is 10.00. So gold will be 10.00 minus 5.9011. Shreya H and Uma Sharma are doing very fast. What about rest of you children? What is it, Arnav? No units? So what is it? Arnav, what are the units of your answer? Oh, it's not 4.1. Sorry. Is 40.1%. How come it is? Oh, yeah. Yes, yes. You're right. You're right. 41%. All of you are right. Shreya R, you and me were wrong. Hmm. Okay. So that's the working of the question based on percent composition. I hope you're understanding this. Now moving on. One last question. We are left with 6-7 minutes. And now this is a mathematical question. I just give you the formulas. You start thinking and guide me how to do it. All of you are going to guide me. So the percent is given, the density is given. How much is there in 50 ml? Yes, please. So what should I assume the total mass of the bleach? Yes. Okay, 100 grams is the mass of the sample. mass of that bleach. So how many grams of NaOCl are there? You know what is the name of this compound? Take out your polyatomic ion list. Is sodium hypochlorite. It's a bleach, the bleach which we are using uh, in the swimming pools also we are using this sodium hypochlorite. So mass of sample is this. So mass of bleach is 5.25 grams. Okay. Now they are asking you how many grams of NaOCl are in 50 ml of the bleach. Now all of a sudden they are on volume. Now we have to see the density. So what do you know about the formula of density? What is density, children? Density of this solution. Density is mass of bleach divided by volume of solution. Am I right? So can you tell me this 100 grams of the sample is present in how many ml of the solution? Use this equation. What do you want to calculate? Volume of solution? This question is different, right? So what is the volume here? Can I say volume is mass over density? Can I say, children? So what is the mass? 100. We assumed it has 100. What is the density? And the answer will be in ml, milliliter. Can you work out this? Ninety point one ml. Okay. Yeah, more accurately, 90.09 ml. So what does it mean, Shreya? It means that your 100 grams of the bleach is present in 90.09 ml, right? But in 100 grams of bleach, how many grams of NaOCl are there? 5.25 gram. So can I say that 5.25 grams of NaOCl are present in 90.09 ml? Can I say that, children? And then can you convert this 90.09 ml as 50 ml? That's what they're asking. And then I need to know the grams of NaOCl. So I'm using this ratio to get the grams of NaOCl. I can do this question by dimensional also, but right now I've done like this. Can you work out this answer? And that will be the answer of the question. So is there any problem in understanding this question? Any problem? You assume the sample of the bleach as 100 grams. You convert this percent into mass. So this mass is present in 100 grams. Then you converted this 100 grams of the sample into milliliter by using this density equation. So the total volume of the solution is 90.09 ml. In 90.09 ml, you have 5.25 grams of NaOCl in 90.09. How much is present in 50 ml? So you can use the ratio the way we were using there in hydrate formulas. You can use the ratio. Okay. Or you can do this dimensional like this. You want to know in 50 ml? So 50.00 ml of the solution times, we know that 5.25 gram of NaOCl is present in 90.09 ml. This is 9 ml of the solution. ml solution cancel. This is dimensional. And you'll get the same answer which you are reporting here. Okay, children, so I think we are done with the percent composition, empirical molecular formula. This unit is very tough. So if you are still worried about it, you have doubts in this, you can stay back in this class or in the next class and you can ask questions. Okay, if something is not clear. And the next class, I will be starting with atomic structure, electron configuration, valence electrons. So the mathematical part is over. Okay, but I want you to practice all the questions of this type from the website, bring your difficulties and bring your doubts. So see you in the next class then. Bye. Bye, Anna.